All right, time for the next talk. Felix Antoine, who flew in from Canada to talk about Magic Castle.
All right, so good morning, everyone. My name is Félix Antoine Fortin. I don't have an exact title at Université Laval, which is in Quebec City in Canada. So I'm guessing I'm some sort of research software engineer working at my university. And today I'm going to talk to you about terraforming the cloud for HPC and mostly for teaching HPC. But I have like greater vision for what is Magic Castle. But first, I like to start this talk with a question for you in order to get you involved and maybe wake you up a bit. Why do you think there are more wizards in Harry Potter than Lord of the Rings? I don't want you to answer it right now. I'm going to provide you some context and maybe give you some ideas of what is the answer, and we'll come back to it. It makes sense at some point, I assure you. All right, so some context. In Canada, we have a global organization that coordinates advanced research computing across Canada, which means, so at the moment, we currently have 5 major HPC sites across Canada, but all of those sites have the exact same software, they run the same scheduler, and they are researchers who use those systems for free are helped by anyone from Canada. So if you are in BC and you speak French, you can get support from Quebec. There's no issue there. So this is our infrastructure, and we also coordinate workshops and training. So across Canada, at the moment, we do around 150 workshops per year. All of those workshops necessarily try to use some form of the HPC software environment we provide, but in order to get access on our HPC system, you need an account at Compute Canada. And generally, you need like 2 or 3 days in order to get those accounts. But if you are a new user or you're just getting your feet wet with HPC, you don't necessarily have an account. So could we do HPC somewhere else than our HPC system when it comes to training, when it comes to development? So could we replicate our HPC environment somewhere else since it's all the same across Canada? Which get us back to the difference between Harry Potter and Lord of the Rings. Does someone has a clue of what could be, why it could be? Yes?
Harry Potter is in the academic sector.
Okay, academic sector. We're getting close. I'm not going to take too much answers, but my take on it, it's wizardry schools. If you had wizardry schools in Lords of the Rings, you would get much more wizards. How do you train wizards? You need to get them in school. You need to train them. But you need schools for that, right? So my proposal is to move away from the Soaring Tower of HPC and more into multiple toy HPC clusters that are out of Legos that look like Hogwarts. Now, how do you do that in concrete? I'm going to do a demo. This is a bit of a reckless demo because I'm going to do it with my phone. I'm going to create an HPC cluster in the cloud with my phone. Now, disclaimer, this is the original idea for that demo is from Casey Neistat from Google. He does it very well. If you haven't seen the demo, go look it on YouTube after this. But if everything goes well, I should be able to create an HPC cluster in around 20 minutes with my phone. So let me talk to Google. Talk to Compute Canada Wizard.
Let's get the test version of Compute Canada Wizard.
Greetings, how can I assist?
I want to build a cluster.
What is the name of your cluster?
Superman.
How many compute nodes?
2.
How many guest accounts should we create?
50.
Okay, you want a 2-nodes cluster named Superman. It will come with 50 guest accounts. Is this correct?
Yes.
cluster will be available in around 20 minutes at Superman, Calcul Quebec Cloud. Thank you for your patience.
All right. Don't get excited. This is just wait. All right. So this might just be a recording, right? Something could have failed along the way. I'm not even sure yet if it has truly created a cluster. So we'll go look at it. So in Compute Canada, we also have multiple OpenStack cloud that are among our federation, and one of them is on Cedar. So I can go look at. So this was my project in Cedar cloud just before the talk. So I'm going to refresh it, and this is where I created my cluster. So if I refresh it, we should see, if everything went well, we should see some instances being created at the moment. So yeah, it worked. So in around 20 minutes, so if we have time during the questions, I could show you up the cluster. All right. So let's get back to the presentation. So what did I do just now? I talked to my Google Assistant, which talked to Dialogflow. So I have a few intents, a few of these questions were pre-canned with Google. Those intents then eventually get some answers from me, and those answers were fed through a REST API in Flask, which was then feeding some of these answers, so just variables, parameters, to Magic Castle that I'm going to present to you. And Magic Castle actually eventually talked with the OpenStack API to create the instances. So we're going to just focus on Magic Castle for today. All of that is just fireworks in order to make Magic Castle shine. So what is Magic Castle? Magic Castle is an open source project that instantiates a replica of a Compute Canada cluster in any major cloud. So I just did it in OpenStack, but I could have done it in Google Cloud, Amazon, Azure, or OVH, which run OpenStack. So it creates instances, management node, login nodes, compute node. So I could, if I had enough resources, I could have 400 compute nodes. No issue there, it scales. It creates volumes, network, security issue. It starts really, as long as you have the quota, it starts from scratch and creates a new cluster and provision it all together in around 20 minutes. So it is available on GitHub if you want to look it up. And my slides should be on FOSDEM website at some point. So it is composed of, Magic Castle is based on two major open source projects, Terraform for creating the infrastructure, and Puppet to do provisioning. So if you don't know about Terraform and Puppet, you can look it up. But those are very powerful tools, and they have both their specific language that do their own thing. So first, we use Terraform to create the instances, and then Puppet to do the actual provisioning of the instances. So when you get Magic Castle, you have to select whatever cloud on which you want it to run. And Magic Castle architecture is decomposed around those files, which are mainly Terraform files, and a cloud in it that will eventually bootstrap Puppet. So we're going to focus for now mostly on the infrastructure. So that would be the infrastructure Terraform file. So as I said, what it creates is a whole HPC kind of cluster that get access from our HPC users. So when my Google Assistant was asking me how many accounts do you need, it was actually creating guest account with a single password that was pre-entered before. So our users can connect on a login node through, yes, the classical SSH, but also through Jupyter Hub. So we have, in Canada, when I'm not working on Magic Castle, I'm trying to push to have Jupyter Hub on all of our system, and I'm using Magic Castle as some form of Trojan horse in order to get our HPC admin to get to know and work, get their feet wet with Jupyter Hub. So the login node has Globus also as an endpoint. So if we want to train our users on how to exchange data between clusters, they can connect with Globus. So all of that is actually, all of the services are provisioned by Puppet later. At the moment, what are being done is the creation of the instance, the firewall, and the router and the access for the users. So when the login node is actually accessible from the internet, the management node is all that are classical administrative services. So we have LDAP, DNS, Slurm is running, Slurm CTLD, Slurm DB is all running on a single management node at the moment. It might not scale to a too big cluster, but again, at first Magic Castle was meant for training. When it comes to storage, what we do is we simply mount volumes, Ceph volumes directly on the management node that are then exported with NFS. Again, we are thinking of different file system at some point, but for now, for training, that was enough. And the actual compute nodes, the one on which the users are going to run their jobs, are simply running Puppet, Slurmd, and console for provisioning, but I'll get back to this later, and Jupyter Hub single user. So when actually a user starts a notebook using the Jupyter Hub interface on the login node, they eventually get their notebook on the compute node. Now, in order to spawn a cluster, I meant this for be used to any research analyst in Compute Canada that don't necessarily know about Terraform. So I wanted to have an interface that is as simple as possible. So we're going to go through that interface. So when you interact with Magic Castle, you just interact normally with a single main file that is decomposed in 4 components. So first you need to select whatever provider, so whatever cloud provider you want to run on with. Then you are going to specify your infrastructure customization. And eventually, if you have, if your cloud provider has some specific parameters, so for example, you run around on Google Cloud with Magic Castle, but you would like your compute nodes to have GPUs, you need to specify it specifically for Google Cloud. And then Magic Castle also takes care of the DNS configuration if you have a domain name. So in my case, when I talk with my Google Assistant, it also registers superman.calculquebec.cloud in Cloudflare DNS and created all of the certificates, SSL certificates required. So when we log in on Jupyter Hub, it's perfectly secure. So first step, you select your provider. Very simple. In the main.df, you have a source parameter. So depending on which release you're gonna get, this is going to point to Azure, GCP, AWS, or OpenStack. The next step is your cluster customization. So when I said Superman to my Google Assistant, what it actually input as a cluster name is Superman. The domain name was already selected. The image is going to be your image on your cloud. So Magic Castle is meant for now only to run on CentOS 7, but if you want to customize your own image, you can specify it through that parameter. And then the number of users, again, this is meant for training at first. So we're going to get, in this case, we're going to get 100 guest accounts that can log in with a password that can specify. And finally, you can specify your public keys. So in order to admin that system, you can connect with the CentOS account and your public keys, so you can manage and administrate your own cluster. Then you can define the different instances type. So when you download a release, it is meant for, there are already predefined type of instances, but if you'd like to get bigger compute node, you can change the type and increase those counts. And all of those parameters can be changed at any point in time in the life of the actual cluster. So if at some point you need 100 nodes and you at first created your Magic Castle with just 1, you could just do a reapply of your current plan. It's going to add 99 nodes, and the cluster is going to adjust and scale by itself. Then you can define your storage. So for now, we only support NFS, and all of those different sizes are for different volumes that are copying the interface that we have on our file system for Compute Canada. So the users have their own home, but they also have a share group project. Yep, and a Scratch folder. Then eventually, you can, as I said, you can input some parameters for some cloud-specific things. So if you'd like to have GPUs and your cloud supports it, if at some point the Puppet provisioning detects some GPUs, it's going to install the CUDA drivers automatically. And as I said, we can support DNS automatically based on the different parameters that were created for your cluster at first. It's going to be registered in this example for in Cloudflare if you have a Cloudflare and a registered domain. Then once you have entered all of your parameters in a single file, you just type Terraform apply, enter, and this is what, again, my Google Assistant did. Eventually, it's going to apply a plan, output the different parameters for your cluster. So the actual password for your guest accounts, the IP address on which you can connect to the login node, etc. One of the challenge that I found when designing this specific Terraform project, if you have no experience with Terraform, was not repeating myself. Since we are supporting around 4 major clouds, it was easy to just copy stuff, but we managed to be able to try to share as much as possible of Terraform codes between the different clouds. As for provisioning, so Terraform is just meant to build the instances. When they are built, there is no actual software that are provisioned. There is no, all of that is missing. So how we do provision the nodes is with Puppet, but we need first to actually bootstrap Puppet because we are starting an all new Puppet master. All of our nodes are running an agent, but we are also running a Puppet master on the management node. So we are using the user data and the cloud in it and all of these different steps in order to bootstrap a Puppet master on the management node. So this was quite a challenge in order to make it all sync. But once this is provisioned, all we have is the management node conductor actually managing the different provisioning between all of the nodes, and everything can be synced. One of the other challenges that are facing when coming to provisioning is that all of that cluster can be put in hand of any research software analysts in Compute Canada that are not necessarily sysadmin. So once this cluster is provisioned, it needs to be self-sustained, and people shouldn't have to do any sysadmin by hand. So it was meant to, so it is quite difficult to actually build Puppet in order to make sure that once provisioned, everything works fine. It's a day-to-day challenge to maintain that data infrastructure. So you might ask, well, you have a cluster, but how does it make it an actual HPC cluster? So we have in Canada, we have those softwares are normally found on our cluster, but the main point is that we across Canada share the same scientific software through a file system that was developed in CERN that is called CVMFS. So all of our HPC systems share the same exact scientific software through CVMFS, which is a file system mounted through HTTP. So since all of our system can get access to that file system, my cluster, my Magic Castle cluster, can also get access to that file system. So all of our scientific software are installed on that file system. So when you spawn Magic Castle, we also mount the CVMFS volume, which provide access to over 4,000 different scientific software that were pre-installed on there. So you get the same exact scientific software environment that you would get on our HPC system. There was a paper that was presented at PERC last year, and Bart Oleman was also in FOSDEM last year to present CVMFS if you have interest, because anyone actually in the world can currently mount CVMFS and get access to our open source software that we compiled and made available through CVMFS. So the key takeaways are all of this wouldn't have been possible with, and you could probably cross Terraform and just replace it by infrastructure as code. So if you'd like to build an equivalent but with Pulumi, that probably would have been possible. But the infrastructure as code is what made us be able to actually build something as complex as an HPC cluster inside a few thousands of lines. And finally, Magic Castle is a teaching and development, I call it a meta platform because it is creating HPC platforms for you to teach or develop new stuff. So again, Magic Castle can replicate a Compute Canada cluster in around 20 minutes, and I can take questions.
Any questions for Félix Antoine?
Did you manage to sell any of this back to the traditional cluster admins?
So you mean the user or the admins?
The admins.
The admins are...
Like Puppet and...
Yeah, actually, so we chose Puppet because we already, in Canada, we already use Puppet to provision our cluster. My idea was to be able to reuse some of our modules. We're not there yet, but because so far Magic Castle is quite self-contained, I'm hoping that at some point they might go and grab some of my modules. Yeah, we are getting there, but not yet. Oh.
Thank you for the talk. I am wondering whether you have any specific reason to choose Puppet, or it was just random?
Yeah, two reasons. The first one I already mentioned. We were already using Puppet in Compute Canada, so it was an easy choice. The other thing, we think about using maybe Ansible, but the fact that we had an agent on the node is actually of value because if at any point my research analyst, which has root on that cluster, delete a file by mistake, the agent in around 30 minutes might find that that file has been deleted and put it back. So it's self-sustained, and with Puppet, I can manage that aspect. So again, I'm putting that Magic Castle cluster in hands of not necessarily sysadmin, so Puppet is kind of doing the sysadmin for me.
Thank you.
Thank you for a very interesting presentation. My question is around the Superman cluster now.
Yep.
Identity management, would I need to have a Canadian identity to be able to log in, and how does that work? And also the life length of a cluster after the workshop, does it disappear?
All right, so the Superman cluster can be, the Superman cluster stays alive as long as I want to. So once I did the apply, I could do the invert, which is Terraform destroy. So in case of our training, we do, depending on the duration of our training, we do either a single day workshop. Well, we keep the cluster open for like 2 or 3 days for people to maybe download their files or keep on playing with it. We have Magic Castle cluster that have been running for multiple months just for development, for example.
Identities for logging in.
All right, so logging in, again, it created a few, in the Superman case, it created 50 guest account that starts with user 01 to user 50. And the password for the superman.calculcabat.cloud is FOSDEM lowercase 20 exclamation mark. You can try it if you like.
Okay.
You can break it. You can hack into it. I don't care because at the end of the day, I'm just going to destroy it. It doesn't matter.
Fantastic. Thank you.
Do you see a tension between your original case of supporting training and workshops and also supporting, for example, if I wanted to use it, I was the one who asked you about Lustre earlier in the week because I would want it to be running real work, maybe on an OpenStack. And do you think that it might make your job as maintainer too complicated to?
No, we are already getting, so we started by training, and then people started asking questions, what is that? It's not an HPC cluster. Can I use that for my own needs? And so I don't know as a maintainer where it's going to get me. So far, at first it was a pet project, and now it's almost a full-time job just for Compute Canada. And I'm curious where it's going to get me now that it's fully open source. I don't know. Maybe my actual employer is going to say you cannot do that anymore. We'll see. But yeah, I'm fully curious on how far we can get that thing, and we are actually getting interns this summer looking to implement maybe Lustre and work on different capabilities that are only provided by some commercial cloud provider, like, for example, the Lustre in AWS, or different networks or different architectures too. So far, we're just running x86 64 kind of architecture, but we could do ARM too.
Okay, that's all we have time for. Thank you very much, Félix Antoine.
Thank you.